Okay, lesson 7.2 is about the Pythagorean Theorem and its converse. The first objective is to use the Pythagorean Theorem, and the second is to use the converse of the Pythagorean Theorem. So first, Theorem 7.4 is the Pythagorean Theorem. In a right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. So the legs are the angles that make the right angle, or the sides that make the right angle, and the hypotenuse is always the longest side. So we use the equation a squared plus b squared equals c squared. So a and b are always legs, and c is always the longest side. Then 7.5 is the converse. It says if the square of the length of one side of the triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So what that's saying is, if we know it's a right triangle, we can use a squared plus b squared equals c squared to find the missing leg. If we know all the different sides, we can test it in that equation to prove if it's a right triangle. That's what the converse means. Okay, Theorem 7.6. The square of the lengths of the longest sides is greater than the sum of the squares of the lengths of the other two sides. The triangle is obtuse. So if the one side is greater than the other two, it's an obtuse triangle because that makes the angle across from it the largest. Theorem 7.7 says that if the square of the length of the longest side of the triangle is less than the sum of the squares of the lengths of the other two sides of the triangle is acute. So if the longest side is smaller than the two legs added together, then it's an acute triangle because that makes that angle smaller than 90. Alright, a Pythagorean triple is a set of non-zero whole numbers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. So any three numbers that you know work in that equation are called a Pythagorean triple. Okay, we got our first example, finding the area. The hypotenuse of an isosceles right triangle has a length of 20 centimeters. So because the triangle is an isosceles triangle, the two legs must be congruent. A squared plus b squared equals c squared, so we're using the Pythagorean theorem to solve this problem. So then, since the two sides are exactly the same, we can substitute x for a and b and 20 for c. So if we add x squared plus x squared, that's 2x squared, and 20 squared is 400. So then if we divide each side by 2, x squared equals 200. If we take the square root of 200 to get rid of the squared on the x, so if we simplify that, 200 is 100 times 2, and the square root of 100 is 10. So we have 10 square roots of 2. Okay, so then we know each leg is 10 square roots of 2 centimeters. Because the legs are perpendicular, one leg is the base and one leg is an altitude or the height. So we know the base and the height are both 10 square roots of 2 centimeters. So now we want to find the area. We know the area of a triangle is 1/2 base times height, and we know that the base and the height are both 10 square root of 2 centimeters. So we substitute that in for both base and height. Then if we rearrange this a little, we can do 10 times 10 and the square root of 2 times the square root of 2. Well, 10 times 10 is 100, and the square root of 2 times the square root of 2 is just 2. So if we do 1/2 times 100, we get 50, and then multiply that by 2, we get 100. So the area of that triangle is 100 centimeters squared. Okay, there is a check for understanding problem here about finding the area of the right triangle. So this is going to be just like this problem here. You're going to have to find the missing length of that shortest side before you start finding the area. Example 2 says, is this triangle a right triangle? So a squared plus b squared equals c squared. We're trying to see if that works. So we're going to put in 4 for a, 6 for b, and 7 for c. And the longest side always goes where c is. So 4 squared is 16, 6 squared is 36, and 7 squared is 49. So then if we add 16 plus 36, we get 52, and that does not equal 49. So since a squared plus b squared does not equal c squared, the triangle is not a right triangle. It has to work for that to be a right triangle. Okay, one more example. Classifying triangles as acute, obtuse, or right. So we are going to check and see if c is greater than, less than, or equal to a squared plus b squared. And it says the numbers 10, 15, and 20 represent the lengths of the sides of the triangle. So c is always the longest side, so we substitute c for the greatest length. So c is 20 squared plus equals 10 squared plus 15 squared. And we know that's 400. And we're checking if it is equal to 100 plus 325. 400 is greater than 325. So since c squared is greater than a squared plus b squared, it is an obtuse triangle. Okay, so there are 2 more check for understanding problems for you. The first one, it says a triangle has the side lengths of 16, 40, and 50, and you need to see if it's a right triangle, so that's going to be like example 2 up here. Second one, a triangle has the lengths of 7, 8, and 9, and you need to classify it by its angles. So you're going to check is c squared less than, greater than, or equal to a squared plus b squared, and then decide whether that means it's obtuse, acute, or right. So go ahead, try out those problems. I will make another video for you to check your answers, and if you have any questions, just let me know.